Welcome to our discussion of whole numbers. These are the objectives. We're going to talk about place value of a whole number. We're going to talk about how to write whole numbers both in words and in standard form, and also how to write them in expanded form. First, some definitions, right? The natural numbers are what we call the counting numbers, 1, 2, 3, 4, 5. If you add 0 into that set, you get the whole numbers. So the whole numbers are 0 out to infinity. The smallest being 0, and of course those 3 dots telling you that they go on and on forever. There is no largest whole number. However, when we talk about digits, digits is the Latin word for finger, and it represents, or it means, the 10 numbers 0 through 9. Those are digits. And each digit has a different name depending on the position in a number. So for instance, the figure below shows how each digit in 108, 474, 611, right, has a different name. 100 millions, 10 millions, millions, and so on. So a whole number that's in standard form is written using the digits in each of the periods. And the periods are separated by commas, and we start at the right. And so we take the last 3 digits on the right, and then a comma, and then the next 3 and a comma, and so on and so forth. That first set of 3 digits is the ones period, then the second is the thousands, and then the third is the millions, and then it goes on and on from there. So you can see that when you have that 108 in the millions, it represents 100 millions place, right? The first one, and then the 0 is the 10 millions place, and then the 8 is the millions place. In the thousands period, the 3 is in the 100,000s, the 7 is in the 10,000s, and the 4 is in the thousands. So you can see this pattern repeats, 110, and then just singular, or whatever the period is. So then the last one, of course, is hundreds, tens, and then ones, because we're in the ones period, right? So that's what helps us understand the pattern of how we can speak these numbers. So if we want to look at just the place value of each bold digit in each of these numbers, well, we can use an abbreviated place value chart to help us identify what each of these are. And so in the first one, we can see that the 2 lands in the ones section of the thousands period. So that's 2,000. But the 8, right, what we're looking for is in the hundreds section of the ones period, so that's the hundreds place. And then if we go on to the next one, right, the 5 is sitting in the tens of the thousands, so that's 10,000s. Part C, we can see that the 4 is in the hundreds place of the thousands period, so it's 100,000s. And with D, we see that it's in the tens place of the millions period, so it's a 10 millions place. Now go ahead and stop the video and try a few on your own. Okay, how about whole numbers in word form and standard form? If we want to write the word form of a whole number that's expressed in standard form, remember standard form is just the number that we're used to seeing, just the digits with commas. Well, then what you want to do is you want to work from left to right, and you need to write down the name of the 3-digit number in each period, followed by the name of the period and a comma. You don't want to write words for periods that contain all zeros. You also don't want to write the name of the last period as ones. And then when you're done, you hyphenate the names for numbers 21 through 99, except for the tens. 30, 40, so powers of 10, right? So for instance, each day in the world, 18,368,924 people have birthdays. Right? That's how we talk. That's how we speak that one. And if you look at how we do it in the periods, we have 18 in the millions period. So that's 18 million. We have 368 in the thousands period. So that's 368,000. And then the last set of 3, 924, and it's the ones, which we don't say anything, so we just say 924. Therefore, as I said, this number is written out spoken out loud as 18,368,924. Please note, pay attention that we never use the word and anywhere in the name. And is only when you have a decimal. So don't put and in your whole number words. All right, here's another example. We can write a word name for the whole numbers in each of these sentences. All right, so we're going to use this place value chart to help us identify the periods. We can see that we have 11 in the thousands period. We have 847 in the ones period. Therefore, the name is 11,847. For the second one, we again use the place value chart. We see that we have 209 in the billions, 996 in the millions, 664 in the thousands, and then 788. We put that all together and we get 209,996,664,788. Again, you'll notice we don't use the word and anywhere. All right, so once again, why don't you stop the video and try a couple yourself. Another thing we can do is we can reverse the direction of the last example we did, and we can write the standard form of a number if it's been expressed in words. And it's really easy. Working from left to right, just write the digits for the number in each period, followed by a comma. That's all you got to do. The comma can be optional for a 4-digit whole number, but I tend to think we should just always put the commas. Sometimes it's left out in a 4-digit number, but I really think it should always be there. So here are some examples. 6,245, right? If we put them into the periods, we see that 6 is in the thousands period, then 245 is in the ones period, so it's just 6, 245. We do the same thing with the others. We've got 79 millions, that's in the millions, right? 26,000, 102. And you'll notice that with the 26,000, because we were missing hundreds, we have to put a 0 in for that place. So anytime you have a missing part of your period, you still have to put a 0 in there when you're doing the word. I'm sorry, when you're writing out the number. So the standard form for 79,026,102 is 79, 026, 102. All right, why don't you guys again stop the video and try these on your own. Okay, how about writing whole numbers in expanded form? Well, the expanded form of a whole number simply breaks the number down using addition and then each digit's value. For instance, let's consider the number 45,368. We can write it into the periods, right? Put it in the 45 in the thousands period, the 368 in the ones period, and then realize that we can see that the 4 represents 4 10,000s. The 5 represents 5,000s. The 3 represents 300s. The 6 represents 6 10s. And then the 8 just represents 8 ones. So if we write each of those out in expanded form, you get 4 10,000s, which is 4 times 10,000, which is 40,000. The 5,000s is just 5,000s. The 300s is 300. The 6 10s is 6 times 10 is 60. And the 8 ones is just 8. So you can really see that the pattern is you're going to use each of these digits and you're just going to start adding zeros, right? The first one doesn't get any one. Then we add a 0 to the second one, 2 to the third one, right? 3 to the next, and 4 to the next. And that's the expanded form of that number. You'll notice how the expanded form uses the place value of each digit to give you the meaning as a whole number, and then uses addition to basically write the original number in terms of the meanings of all of those digits. It's just kind of breaking it up and showing you how you could add things as just multiples of 10. Let's try another example. We can write each of these numbers in expanded form. You'll notice that we didn't put a comma in the 4,276. See if you like it. I personally don't. I'd put a comma in there, but it's okay either way. So here's the solution. 4276, we write them into our periods. We see that 4 lands in the 1,000, so that's 4,000s, right? 2 hundreds, 7 tens, 6 ones, so there's your 4,000 plus 200 plus 70 plus 6. We can do it again for part B. Put everything into the place values, right, into the period parts. And you have to realize that if you have a missing digit, like so for instance, we have a 0 there in the thousands, right, the 1,000s place, you don't want to add 0. So when you break it all up, you've got 30 million plus 2 million plus 700,000 plus 40,000, but then you don't put plus 0,000. You just leave that out and you skip and go plus 900 plus 40 plus 5. Lastly, go ahead and stop the video and try these two on your own, and that's all we have for you today.